Welcome to EDU World Space.
This question asks us to stretch the structure of 4 different complexes and give the full compound name. So we'll start with part A, and we'll probably need a couple of pages to show this out because I want to be able to give pretty big drawings. So we'll start with drawing out this structure. So we have our center metal of CO, excuse me, and we know this is going to be an octahedral complex because there are 6 things attached to this center metal. There's 4 NH3s and 2 H2Os, and we know that it's going to be a cis structure. So I'll go ahead and draw the lines for the octahedral complex, where you have 2 going up and down, and then the 4 other ligands, 2 going behind the page and 2 coming out of the page. Now, in order to have a cis molecule, we need I like to think of it as the thing that has 2, this H2O, those need to be on the same side. So we'll go ahead and put those OH2 and OH2. If this was a trans configuration, you would put these OH2s on opposite sides, so maybe one up here and one down here. And then we can just fill in the NH3s. NH3. So we have 4 of them. And this is our whole coordination complex. And then we have NO3 2 on the outside. So you know that these NO3 2s contribute a -1 charge overall, so this is going to be a -2 charge. And because this whole thing is neutral, that means that this complex has a +2 charge. We can then determine the charge of the cobalt because we know the charge that these ligands contribute is 0. So we know that this cobalt is a +2, and that will help us in our naming. So with the name, we'll start out with indicating that this is cis. That goes first. We're then going to describe the ligands attached to the metal, which we have this NH3, which is an amine, and we have this water, which is aqua. And this goes in alphabetical order based on ligand. So amine AM comes before aqua AQ. We have 4 amines, so this is going to be tetra on our Greek, tetraamine. Then we're going to have 2 waters, so we have di-aqua, and then our CO cobalt, and we know it's a +2 charge, and then nitrate. And I'm going to put this down. There would be a space between the cobalt 2 space and then nitrate. And this tetraamine diaqua cobalt is all 1. There's no spaces in here. Okay. We'll start with the second, where we have this part B, where we have Na2, Ru, H2O, Cl5. This is again an octahedral complex because there are 6 ligands attached to our central metal. So we're going to have Ru, 1, 2, 3, 4, 5, 6. And no matter how you put this, it doesn't matter where you put this H2O, so we'll just put it over here, and then Cl, 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 Cl. This is our complex. That cut off a little bit there. And then we have our 2 NAs, which is a +2 charge overall, so we know that this is a 2- is 2 charge. That tells us if our Na is a +2, our Cls are a -5, our H2O is a 0. That indicates to us that our metal is a +3. And so when we write that out, we're going to start with the positively charged anion first. So we've got a sodium and then a space. We're going to describe the ligands first. So we have this water or aqua, which is going to come alphabetically before the chloro. So, and we only have one, so we just call it aqua. We have 5 chlorines, so we have penta. And then to describe the chlorine, we're going for the chloride ions. It's going to be chloro, so that's CHLORO. And then our metal is going to end in ate because it's part of the anion. So it's going to be RUTHENATE, and we know that it's a 3 charge, and that is our name for part B. Part C is trans NH4, and then our metal ligand center is cobalt C2O4 2, and then H2O2. Close. So we again know that this cobalt is going to be a octahedral because it has 2 waters and then this 2 oxalo ion that is a bidentate ligand. And so there's going to be 6 things attached to this cobalt. So we're going to have CO 1, 2, 3, 4, 5, 6. And this is trans, so we're going to go ahead and put these 2 waters on the top and bottom. So OH2, and then we're going to draw the this C2O4 on this side and this side. So I'm going to put the O's, which are attached, and then those go out to carbons, which are double bonded to another oxygen. Then we're going to draw the same thing on the other side, the CCO. Well, and these guys all have lone pairs. Okay, this is our ligand, and then we have the NH4 here, which is a positive charge, and so this whole complex is going to be a -1 charge. The water does not contribute to the charge. The C2O4 is a -2. There's 2 of them, so it's a -4. With the NH4 of a +1, we know the cobalt needs to be a +3. And so when we write that out, we start with the cation, so it's going to be the ammonium. So there we go. And then I'm going to start the anion on the next line, even though it would just be a space. I just know I'm not going to be able to fit that whole thing there. And we're going to start with the trans, starting with our water, because it's an aqua, so it would come first alphabetically. So we have di-aqua, and then we have 2 of the C2O4, which is an oxato, so di-OXA-LATO, and then we have cobalt, and then this needs to end in 8 and 3. It's a 3+. Our last, part D, is a cis Ru En2 Cl2, where we know that this En is a bidentate ligand and there's 2 chlorines, so you know it's going to be an octahedral complex where you have Ru down, 2 coming out of the page, 2 going into the page, and we know that it's cis, so we'll go ahead, we'll just put those chlorines on the same side, not opposite each other, and then I'm going to abbreviate the En with a nitrogen and then connecting it just to the other nitrogen. So we're just going to put an N, and then this little fan, and that designates one of these En molecules. And then we have 2 of them. We're going to connect them like that. And then for the naming, we need to determine the oxidation state of this metal. The only, this En does not contribute a charge. The chlorine contributes a -2 charge, so the Ru needs to be a +2 charge. So when we name this, it's going to be cis, and then the ligands, the chloride ion would come first. There's 2 of them, so it's dichloro, and then there's 2 ethylene diamines, or En, so that's THYLENE, diamine, and then our metal is ruthenium, RUTHIUM, and we know that it is the +2 charge. So